Hello, my wonderful, wonderful children. We are on to our next lesson. Today, this is all about the least common multiple. And I know I've switched up my computer here, my screen. We now got a black background with some lighter color markers. We're seeing how this works. I don't know. We're trying it. If you don't like it, let me know. If you do like it, maybe I'll keep it. I don't know. Don't get distracted by that. Let's focus on our math. All right. Least common multiple. Last time we talked about greatest common factor. And so here's a little helpful hint. Factors are the smaller numbers. And today we're going to be dealing with multiples, which are the larger numbers. More specifically, a multiple is the product of a number and a non-zero whole number. Right? You know multiples. So I want to say, all right, what are the multiples of 5? You would say, okay, well, this is just skip counting. Multiples are skip counting. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and continue on forever. Then if I said, okay, well, great, what about, what are the multiples of 3? Okay, well, this is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, continuing on forever and ever and ever. All right, we know multiples. Multiples are just counting in lists of numbers here. But we are looking for the least common multiple. So just like greatest common factor, we're going to be finding the multiples that are in common in 2 or more numbers. But this one, we don't want the biggest number that's in common because we might never find that. We want the first number or the smallest number that is in common between 2 or more multiples. So if we were to look at our multiples here of 5 and 3, we could look and say, all right, where on this list do we have numbers in common? Well, it looks like we have a number here at 15 and 15. Those are both in common. There's nothing smaller in common in either of those two values. So our least common multiple, or LCM, is 15. So the least common multiple is if we made a list of all the multiples and we found the first 2 that were in common, that would be what our multiple is. Okay? But just like we did last time, we talked about greatest common factor, and there's a different way to find it instead of listing all the multiples out, because your list might end up being really, 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 really big. We want to talk about how to solve this with prime factorization. Okay, so an example of that, I'm going to tell you the answer first, actually. The answer is the least common multiple of 78 and 110 is 4,290. Okay? So if I were to say, hey, what is the least common multiple of 78 and 110? And you didn't know, which you shouldn't know until right now that I've told you, but you wouldn't know, and you go, okay, well, let me start with making a list. All right, well, I have 78. So my first one, 78 times 1 is 78. 78 times 2 is 156. 78 times 3, oh, no, this is miserable. Let me try 110. 110. 110 times 1 is 110. 110 times 2 is 220. 110 times 3 is 330. Okay, I'm getting this one. This one's not terrible. You would have to do this 39 times to get to 4,290. 110, you'd have to write down 39 different multiples. 78, you would have to write down 55 different multiples to get to 4,290. So I want to make this a lot easier so you're not writing down lists of 55 multiples of 78. Because again, who knows anything about the multiples of 78? Because I sure don't. So let's deal with how to do this with prime factorization. Okay, so we know our answer. Our answer is 4,290, but I'm going to break down on how to do the prime factorization of this. So we want the prime factorization of 78 and 110. Let's go with 78 first. 78 breaks down into 2 times, what is this? I believe it's 39. 2 and 39. 2 is prime. 39 can be broken down into 3 and 13, where 3 is prime and 13 is prime. So 78 breaks down into 2 times 3 times 13. That's not one we like to deal with. We don't like our 79s. Or 78. What a lame, terrible number. Who likes to multiply things by 13? Not me. It's like a terrible number, but it's okay. All right, then we break down 110. And 110 breaks down into 11 times 10. Remember, the zeros are good here. 11 is prime. 10 breaks down into 2 and 5, which are both prime. And therein is our prime factorization. 2 times 5 times 11. Yikes. This is not a fun one. Okay, so we have our prime factorizations. And the way that least common multiple works for our prime factorizations is we want to, again, find the ones in common. Just like we did for greatest common factor, we want to find our common factorizations here. And here we have some 2's. Okay, and these 2's will simplify together to make 1, 2, just like we did before. The new thing is we're going to take this 2 here and we're going to times it by everything else that's not grouped together. So 2 times 3 times 5 times 11 times 13. That is not a pleasant experience for anyone, but we're going to do it. We're going to get through it here. Oh, whoops, this shouldn't be another 2. This should be a 2 times 3. There's our 3. There's our 2's, our 3, our 5, our 11, our 13. All right, let's try and deal with some things that we like. Some easy multiplication. 2 times 5 is 10. 10 times, actually we'll do 3 times 11 is 33. We'll do a 10 times 33 times 13. 10 times 33 is 330. And as we all know, 330 times 13 equals 4,290. And the way I know that is because I told you that was my answer from the very beginning. All right. Whew. Let's back up. Let's do some that aren't going to get us such large, terrible numbers. All right. Let's find a little bit of a better situation here. Let's say we want not these least common multiples. We never want these least common multiples. They look and feel and sound atrocious. Oh, I don't know what happened there. But delete all that. Okay. All of this, get rid. We want to know the least common multiple of, let's say, 18 and 27. 18 and 27. All right, so let's find our prime factorization of 18, prime factorization of 27. 18 breaks down into 3 times 6. 3 is prime. 6 is 2 and 3. So 18 is 2 times 3 times 3. 27 breaks down into 9 times 3. 3 is prime. 9 breaks down into 3 and 3. So 27 is 3 times 3 times 3. Let's group some things in common here. We've got a pair of 3s. We've got another pair of 3s. Then we have a 2 and a 3. Then we take these pairs. They become one value. And we write a whole multiplication problem multiplying everything together. So we have a 2 from right here times a 3 from right here times a 3 from right here. I like to cross off as I go so I know what I'm doing. Times a 3 right here. Then we multiply all this out, and we say, all right, well, 2 times 3 is 6. 3 times 3 is 9. 6 times 9 is 54. And our least common multiple of 18 and 27 is 54. They get us there. We'll get there. And it totally works. That's exactly what we need for it to do to be working. All right. Now, let's see what happens when I have prime factorization of numbers that are bigger, or that I have more than one common number. Okay, or I'm all over the place here. Prime factorization of 3 numbers. We're going to see what it looks like when I have prime factorization of 3 numbers here. Where's my delete? Delete and delete all that. All right, I want the least common multiple of, I'll say 8, 12, 18, and 20. We'll go with 4 numbers. We'll go with 8, 12, 18, and 20. All right, let's start working through this. 8 breaks down into 2 and 4. 2's prime. 4 breaks down into 2 and 2. Lots of 2's here. 2 times 2 times 2. All right. 12 breaks down into 3 and 4. 3 is prime. 4 is 2 and 2. 12 is 2 times 2 times 3. 18, we just did this one. It's 9 and 2. 2 is prime. 9 is 3 and 3. We have a 2 times 3 times 3. And then 20. 20 breaks down into 4 and 5. 5 is prime. 4 is 2 and 2. All right. I know I did a lot of the prime factorizations quickly. Hopefully we can be able to be doing that quick, be able to understand that part so we can focus on the LCM part. All right, now, like I did before, I want to go through and look for things in common. So here, I have some 2's in common in everything. Everything has a 2 in common. And if we look, we go, oh man, that's everything that's in common here. That's the only thing we have that's in common in all of these values. But what's nice about LCM is things don't have to be in common in all the values to count. We can say, hey, guess what? I actually have some 3's that are in common here. I'm going to circle them. And I have some 2's that are in common here down to this bottom row. And I'm going to circle those 2's. And now I have a 2 left over, a 3 left over, and a 5. I have nothing left over that's in common with something else, so I'm okay. So I can group things with least common multiple. They don't actually have to be in common in all of the numbers. They can just be in common in some of the numbers, and it will still count, which is kind of nice for this least common multiple. All right, now I'm going to take this and I'm going to start multiplying out. So I have all of my 2's here become a 2. All of these 2's here that are in a group become another 2. This 2 becomes another 2. I've got a group of 3's to give me 1 3. I've got another 3 to give me a 3. And I've got a 5 to give me a 5. All right, now let's start multiplying out where we see fit here. We have a 2 times 5, which equals 10. I always like to get to 10s if I can. 10s are nice. They're nice to deal with. I have a 2 and a 3, which is 6. And I have another 2 and a 3, which is 6. So I have a 10 times 6 times 6. 6 times 6 here is 36. And 36 times 10 is 360. These 4 numbers don't have an overlapping multiple until we get all the way to 360. It's a big least common multiple. Not as big as 4,290, but it's still a very large least common multiple. All right. How do we feel about the LCMs? Hopefully they're okay. Hopefully they're not miserable. Hopefully you can survive. Love you. I will see you all in class tomorrow. Have a great, wonderful rest of your day. Enjoy this lesson. If you have any questions, please let me know. Bye, children.